Hello and welcome to my video 5.1b, restrictions on a variable. So for square root functions or square root expressions, we just have to remind ourselves about a fact from the last video, which is that square root of -1 is an error in your calculator. So basically we can't get square root of -1. That would give us I, which is an imaginary number. It's a special type of number. So if you think back to Math 10C and the different types of number sets, we've got real numbers and we have imaginary numbers. And we don't talk about imaginary numbers in high school. That's a university concept. So we're going to avoid that error or that issue by putting a restriction on the variable. Okay? So the restriction on the variable will prevent the inside of the radical being negative. Okay, so how do we do that? Well, if we take a look at any one of these examples, all we have to do is start by making the inside greater than or equal to 0. So this first one is easy. There's nothing else to do. It's just greater than or equal to 0, where x is in the real numbers, but usually we won't even write that part. We'll just write the first part. Okay, and then the second one is a little bit more complicated. A plus 3 is going to give us a value bigger than 0. Now we need to solve for a, though. We want to put a restriction on the variable, not a restriction on the variable and numbers. So now we do some opposite operators. So we move the plus 3 over by doing minus 3. So a must be greater than or equal to -3. All right, taking a look at the next one here, we've got 3c minus 5 must be greater than or equal to 0. Then we're going to move the 5 over, so we're going to have 3c is greater than or equal to 5. And then we're going to divide by 3 on both sides. So c is greater than or equal to 5 over 3. All right, pretty simple process here. Let's keep going and find some more challenging questions. So here, well, actually, before we keep going, let me just go back to one of these examples and come up with a way of testing that we've done this correctly. So this is saying that a must be greater than or equal to -3. Don't try the equal to position, but try something that's greater than -3. So something that's greater than -3 is -2, right? So what we're going to do is we're going to take the -2 and put it instead of a to test or verify our solution. So what you're going to see here is that -2 plus 3 gives us 1, and so that gives us a positive inside, which lets us solve this. So you can see that it's verified here, and you can do that for all of these. Now, watch this next one. Okay, this one's interesting. 9 minus 3y must be greater than or equal to 0. That's true. Now, normally when we solve this, what we would do is we would subtract 9 on both sides. And so far, this is also true. But if we divide by a negative or multiply by a negative, like we are about to do here, 9 divided by 3 is 3, and it's double -9 and -3, so it goes to positive. When you do this, you're going to find that this actually doesn't work. So we have 4 is greater than or equal to 3, right? And then if we verify that, 9 minus 3 times 4, what we end up having is 9 minus 12, which you can see is -3. That doesn't work. This is a problem. It doesn't work. So it did not verify. So what we need to do is we need to change something. We need to have a rule that we can do that will fix this. So the error is right here. Okay? So what's going to have to happen instead is it's going to be y is less than or equal to 3. So the rule is if you multiply or divide by a negative, then flip the sign, the inequality. Okay, important rule, don't forget it. There is a way to avoid this issue here, so let's take a look at how we could avoid this by starting back at the beginning. 9 minus 3y is greater than or equal to 0. What if we move the y over? So if we added 3y to both sides, well, would you look at that? When you divide, you get 3 is greater than or equal to y. You're going to notice that the y is on the smaller side and the 3 is on the bigger side. So it ends up being that both of these methods are correct. Okay, let's take a look at the next one. So we're going to go through the regular process here. 2x squared has to be greater than or equal to 0. What you're going to notice here is if you divide by 0 by 2, you still have 0. If you square root 0, you still have 0. But what's interesting here is that because of the square on the x, if you had, let's just talk about on the side here. If x equaled -1, then x squared is 1, a positive 1. If x is 1, then x squared is also 1. So a square symbol automatically makes the result always positive. And so because of that, this statement is actually always true, which means that when we get rid of the square root, what we would actually write is there is no restriction on x, or we write it like this: x is in the real numbers. All right, let's take a look at the next one. B squared minus 4 is greater than or equal to 0. So if we move the 4 over, b squared is greater than or equal to positive 4. Then we're going to square root both. Now this is going to be a very interesting one, because when you square root a square, it means that we're going to have a positive or negative b, giving us that square root of 4, which is 2. Which means that another way to say this is, or another way to write this is to move if you move the negative over. So like one version of this is like this, and that's fine. Nothing is wrong here. So this is true. However, the other version is the negative version. And like we said about the negative version earlier, if you divide by -1 or multiply by -1, you must flip the sign. So this is the other statement that's true. So both are true in this example. So that makes it a little bit more complicated, but we've seen examples like that before on a graph. Let's just think about if this, this should be a negative here. So this is saying b is less than, yeah, here you go. So let's just quickly draw a graph that looks like this, so you can kind of see what I'm talking about. Or at least a graph that has a restriction that looks kind of like this. So if this was -2 here, okay, this graph kind of shows, or let's just talk about a number line. It's probably easier to think about it as a number line. Okay, and then this here is +2. And you can see the part in the middle is not included. So that's kind of what this is showing here. So we could write this as -2 is greater than or equal to b, which is greater than or equal to 2. This is outside notation. So you either have to write both of those, or you have to write this one. Okay, both ways are fine. Either write it together or write it separately, but both are necessary. Okay, let's take a look at the next one here and our last one for today. So in this example, is there any restriction on the variable? Well, no, there is not, because anything inside a cube root doesn't have that problem. So because this is a cube root, the inside can be negative. And that is an interesting fact here. All right. So I hope this video helped you better understand restrictions on variables, and good luck.